चैंपियन कोर्स किन के लिए है? जो IIT JEE एडवांस का एग्जाम दे रहे हैं, मेंस का एग्जाम दे रहे हैं, उनके लिए है। ये कैसे ज्वाइन कर सकते हैं? आपको यूट्यूब चैनल पे जाना है, वहाँ पे ज्वाइन बटन है, मेंबरशिप लेना है यूट्यूब का। आप मेंबरशिप लोगे तो मैं इस कोर्स को ज्वाइन कर सकते हो। इसमें आपको पूरा कोर्स करवाया जाएगा, आपका लाइव डिस्कशन होगा, DP दी जाएगी, यानी पूरे ऑर्गेनिक केमिस्ट्री की कोर्स की गारंटी अच्छे से करवानी आपको सिखाने की मेरी होगी। तो आप ज्वाइन कर सकते हैं यूट्यूब के मेंबरशिप प्रोग्राम के थ्रू। ज्वाइन बटन पे क्लिक। हेलो, तो टुडे वी आर गोइंग टू स्टडी conformers. Now what is the meaning of conformers? Now before starting conformer, I want to show you something. For example, I am moving my hand like this, or I am moving my hand like this, or I am doing this. What type of isomerism I am doing? For example, I am doing some boxing, stretching. What is the type of isomerism I am doing? They are known as conformers. The type of isomerism is conformer. Now what is the meaning of conformer? Conformer means isomer formed by rotation across sigma bond. If isomer formed by rotation across sigma bond, for example, this is a ethane molecule. If I rotate this carbon-carbon bond, and these different forms are known as conformers. So isomer formed by rotation across single bond is known as conformers. Now what is the exact definition? The different space arrangement of the atom, the arrangement of atom in the space that result from the rotation across single bond is known as conformers. Means there is a different arrangement of atom in the space formed due to rotation across single bond is known as conformers. Got it? Now, first of all, I want to see you, let us check some basic data. The carbon-carbon bond rotation energy needed is 12 kilojoule per mole. And for carbon-carbon bond cleavage, energy needed is 260 kilojoule per mole. And the energy available at room temperature is 80 kilojoule per mole. So first of all, write down the definition and write down these data. Then I will explain further. Pause the video and write definition along with these data. Now, if I show you two different molecules, this is ethene and this is ethane, and I want to explain you which will undergo conformational isomerism or which organic molecule will form conformer. Now in this ethane, if this is a rotation, conformer is possible, while in ethene we cannot form conformer, because to form conformer we have to break this pi bond. If I rotate this bond, this pi bond will break. This means carbon double bond carbon will not show conformational isomerism. In order to show conformational isomerism, we have to break this pi bond. If we will break this pi bond, then we will rotate, then the conformer are possible. But as we know that energy needed for CC bond rotation is 12 kilojoule. And if I am rotating this bond, how much energy is needed? 12 kilojoule per mole. But if I have to rotate this bond, I have to break pi bond. And how many energy needed? 260. And this energy is not available at room temperature. Mainly the conformer formed are at room temperature. So whatever discussion of conformer is going on, the temperature is room temperature. Got it? This means 80 kilojoule energy is available at room temperature. This means ethane can form conformer at room temperature, ethene cannot. Got it? In simple word, single bond rotation across gives conformer. Double bond will not give us conformer. Got it? Now let us check different projections. Now this type of projection is known as Chouhan's projection. First I will check Chouhan's. These are known as Chouhan's projection. In this case, these hydrogen are parallel, means it is a 0 degree. It is known as eclipse conformer. Now what is the meaning of eclipse? If the HH angle is 0, it is eclipse, and this projection is known as Chouhan's. And if I rotate this by 180 degree, after 180 rotation, the HH angle is 180 degree and it is known as staggered conformer. Both are Chouhan's projection. But if the HH is parallel, it is 0 degree. If HH is 180 degree, it is staggered conformer, it is eclipse conformer. Both are Chouhan's projection. Just write in your notes. First of all, write in your notes. Now, I will explain this by model. The molecule of ethane, which is in my left hand, is a eclipse conformer. As you can see that these hydrogen are parallel to each other. Parallel means they are eclipsing. Now, in order to form staggered conformer, what should be the rotation? The rotation must be 180 degree. Either it can be clockwise or anti-clockwise, it doesn't matter. So, I will rotate this bond by 180 degree. As you can see, initially it was eclipse, HH is parallel. If I rotating this bond, now it is staggered. This is eclipse, this is staggered. You can see by different angle. This is eclipse, this is our staggered. Got it? Now, this type of projection is known as Chouhan's. Now, I have to convert this source into Fisher, a Newman. This type of projection is known as Newman. How will you convert this Chouhan's to Newman? That I am going to teach you. What you have to do, in the back side, the carbon which is on back side, draw a circle on back side carbon. Draw a circle on back side carbon. Delete the bond in between the circle. Delete the connecting bond and bond in the circle. You will get this. Now, what you have to do, just put this carbon on this circle. Pick up this carbon and put on the circle. Pick and put. Got it? You will get this. This is known as Newman projection in staggered form. I will explain you once again. Draw the circle, delete the connected bond, delete all the bond which is in the circle. You will get this. Now, pick this carbon and put on the circle. We will pick and put, we will get this Newman projection in staggered conformer. Now, similarly, if we have to convert Chouhan's to Newman of eclipse. This is our staggered and this is our eclipse. What you have to do? Draw the circle, delete all the bond in the circle, delete connecting bond and put this carbon on. We will get this after deleting. Now, put this carbon on this, you will get this. This is our Newman projection in eclipse conformer. These projections are known as Newman and these projections are known as Chouhan's. Pause the video and write in your notes. Now, which one is more stable? We have two different Newman projection. This is Newman projection in staggered form and this is Newman projection in eclipse. And eclipse is unstable, staggered is more stable. Although staggered is a Greek word which means stable. The word staggered means stable. And eclipse, as you know, there is eclipsing. You usually see in universe there is a eclipsing, different partial eclipsing, fully eclipsing. The hydrogen is hiding behind this hydrogen is hiding behind this hydrogen, therefore it is known as eclipsing. So, first I want to explain that the term staggered means stable, the term eclipse means hydrogen behind another hydrogen. Got it? Now, this eclipse is unstable. Why it is unstable? Two type of strain is there. If the HS is repulsion, this repulsion due to size is known as steric strain. So, first of all, there is a steric strain. Second, there is a bond pair repulsion. This is known as torsional strain. So, two type of strain is in eclipse form. One is our steric strain because of size. Another is torsional strain, means bond pair repulsion. So, note down in your notes that staggered is stable, eclipse is unstable. Now you have to convert, write down all these examples, and you have to convert, draw the Newman conformer. And basically what you have to do, you have to convert Chouhan to Newman. Convert all this, and then check your answer. First think about how this source will convert into Newman. First you should think, and then you should check your answer. This is correct. We have to draw circle, and we will put this carbon on this circle. You will got this. This is correct. This is wrong because different valency are there. We will draw circle and put this carbon on this. So what is the Newman projection? Chloro-bromo-methyl acid chloro-bromo. This is the Newman. Got it? Try this. Similarly, you should try these example 3, 4, 5. You have to convert Chouhan into Newman projection. Pause the video. Now, how to convert this Chouhan into Fischer? You have to simply draw a circle. Draw a circle. Delete all the bond in the circle, delete connecting bond, and put this carbon on this. You will get this. Similarly, we can draw for this. We will put this carbon on this circle. We will got this. Similarly, draw circle, delete all the bond in the circle, delete connecting bond, and put this carbon on this. You will get this. Got it? Let's try some more example. Now try this 6, 7, 8. In all these, again you have to convert. These are the Chouhan, and you have to convert into Newman. You should not check the Newman answer. First of all, just write the Chouhan, write your answer, then check with the given answer. Don't try to see answer before attempting the questions. Now, what is the answer? We will draw circle. We will put this carbon on this. This is correct. Similarly, we draw circle. We will put this carbon on this. This is again correct. We will draw the circle. Now, instead of this, we will draw circle, and we will put this carbon on this. This means we will get Br, H, and methyl. And the back side, we will get methyl. Then there is a Br. Then there is a H. Got it? This is your correct answer. So hopefully now you are very clear which conformer is more stable, eclipse or staggered, which is more stable. Staggered is more stable. Why staggered is more stable? Because of steric strain and torsional strain in eclipse conformer. And second thing, we studied in this lecture that how will you convert this Chouhan into Fischer. So this is a simple technique to convert this Chouhan into Fischer. Now we will study how to convert this Chouhan into Fischer projection. Yani we have to convert to Fischer projection. First of all, what is the Fischer projection? In Fischer projection, there is a vertical line and there are horizontal lines. Vertical line represent below the plane. Vertical line represent below the plane, and horizontal line represent above the plane. Now we can understand Fischer by this eclipse conformer. This is our eclipse conformer. You got it? If I pass the plane from these two carbon, these two valencies are above the plane. Means horizontal line valencies are above the plane, and the vertical line valencies are below the plane. If you watch this model, you will see one vertical line and you will see two horizontal line. Got it? So this means that this is the Fischer projection. You convert this into Fischer projection. This is the Fischer. If I match this molecule with this model, then what I will get? White represent hydrogen. This is our hydrogen, this is our hydrogen. And this color represent OH. This is OH, this is OH. And this color represent acid and acid. Got it? These two are hydrogen, these two are OH, and these two are acid. Means the eclipse conformer will convert into Fischer projection. Now, this is our eclipse conformer. If I want to convert into Fischer, what you have to do? First of all, you have to draw eclipse conformer. We cannot draw Fischer projection of staggered conformer. Now, what happened in staggered? This is our staggered conformer. In staggered conformer, if we draw vertical line represent valencies below the plane. But if we consider staggered conformer, one valence is above the plane, another is below the plane. This means we cannot draw vertical line in this staggered conformer. What we have to do? We have to convert staggered into eclipse. Then we will draw Fischer projection. Now let's check this. This is our front carbon. Let us assume this is our back carbon. And from this is front carbon, this is back carbon. Means I am, for Chouhan's projection, I am watching from this carbon-carbon bond, and this is our Fischer projection. Now, this acid and hydrogen are on right-hand side. H right-hand side, both hydrogen on right-hand side. OH on left-hand side. OH on left-hand side. Now, similarly, if you have to draw this Fischer projection, one more thing is important in Fischer. Whenever you have to draw Fischer projection, draw in such a way that maximum carbon must be on vertical line. According to IUPAC, maximum carbon must be on vertical line. Maximum carbon must be on vertical line. So whenever you have to draw Fischer, maximum carbon should be on vertical line, so that all people will draw one Fischer. Otherwise, what happen? Some student may put hydrogen here, some put acid here, some put OH here. There are multiple Fischers are possible. The best way is maximum carbon must be on vertical line. Now we have to draw this Chouhan's to Fischer. First of all, this is staggered conformer. So we have to convert into eclipse. We will rotate this by 180 degree. This methyl come here. After 180 rotation, H come here. After 180 rotation, this Cl will go there. Got it? This will form. Now what you have to convert? What you have to draw? Methyl on vertical line. This is our front carbon. This is our back carbon. This is front. This is back. In front carbon, Cl on left hand side. In back carbon, Cl on right hand side. It is on right hand side. Got it? So in case of staggered, you have to convert into eclipse. In case of eclipse, you can directly convert into Fischer. Pause the video and write maximum carbon must be on vertical line, and carbon containing functional group must be at top of vertical line. Maximum carbon must be on vertical line, and if there is any functional group, then carbon containing functional group must be at top of vertical line. Always, while naming IUPAC nomenclature of that particular molecule, the numbering should be start from top to bottom. Means the carbon containing chain must be up from top to bottom. This means that carbon containing functional group must be at top. Now pause the video and convert all this into Fischer projection. Then you can check your answer. Now in this example, this is our eclipse, methyl. We will draw methyl here. In this is carbon, Br right. Both bromine must be on right, HH on left. This is correct. Similarly, this is our eclipse, methyl on vertical line, Br right. Both Br right. This is correct Fischer. Similarly, phenyl, H on right, OH on right. This H on right, this means the Fischer will be phenyl. In this carbon, OH left, H right. H left, OH right. This is our Fischer projection. Got it? You have to convert into eclipse conformer, and maximum carbon must be on vertical line, and carbon containing functional group must be at top of vertical line. So write in your notes, maximum carbon must be on vertical line of Fischer projection, first of all, write eclipse conformer convert into Fisher projection. Eclipse conformer convert into Fisher. Second, maximum carbon must be on vertical line of Fisher projection. Third, carbon containing functional group must be at top of vertical line. Now convert this into Fisher. Pause the video and convert. What you have to do, first you have to convert into eclipse conformer. We will rotate this by 180 degree. This means this is methyl, methyl. This chlorine on right hand side, and after 180 rotation, the Br will be go in this position. There will be Br on this position. It is also on right hand side. This means chlorine right, Br right. This is correct Fisher. Similarly, this is a staggered, and we have to draw Fisher. For Fisher, we have to convert into eclipse. Got it? In case of eclipse, what you have to do, after 180 rotation, we get this acid, acid, OH right, OH left. OH right, OH left, this is correct. Got it? So in this lecture, we learn how to convert salts into Newman. We also learn how to convert salts into Fisher projection. In next lecture, we will discuss the different conformer stability, how different conformer are forming, what are their energy, how their stability are affecting. We will discuss stability and other factors in our next lecture. First, we will discuss the open chain molecule. Then in further lectures, we will discuss closed chain molecule. If you have any doubt, you can ask in our comment section. Thank you. Have a nice day. Now let us explain eclipse and staggered by this 3D model. The left hand side is our 3D model of the staggered conformer. Now this is 3D model, white represent hydrogen and black represent carbon. This is the way in which we draw in our notebook, and this is the actual model in 3D. Now you can see that staggered. Now I am converting this staggered into eclipse by rotation of this carbon-carbon bond. Now after that rotation of carbon-carbon bond, we will get eclipse conformer. That was written on right hand side of that page. So this is the eclipse conformer, and this is the actual model. Now all these white are at, white means hydrogen, are at eclipse form. Now you can easily watch by 3D and the actual whatever we written in our class notes.